Hello, I am Alexander Krah. In this video, I would like to present a high-scale infrastructure project recently completed in the Philippines. This project is a critical component of the National Flood Control Initiative. The pipeline was manufactured by Krah Pipe Manila Inc., our certified local partner. We are looking at a nominal diameter of DN3500, spanning a total length of 1 kilometer. The system includes several integrated manholes, all connected using the unique Krah integrated electro-fusion technology. This ensures a completely homogeneous and leak-tight joint throughout the entire network. Engineering excellence made by Krah pipes. Let's take a closer look. The Philippines' geographical location presents unique engineering challenges. Situated within the Pacific Ring of Fire, the region is highly prone to seismic activity. This necessitates the use of flexible pipe systems that can withstand ground movement without compromising structural integrity. Furthermore, the country faces extreme weather patterns driven by El Niño and La Niña cycles, resulting in frequent typhoons and intense rainy seasons. These conditions demand robust infrastructure to manage massive water volumes. In cities like Marikina, rapid urban development has disrupted the natural water cycle. Urbanization has hindered natural infiltration and groundwater recharge, leading to what we call a half-water cycle. Our flood control projects are specifically designed to address these historical planning gaps, providing critical drainage solutions to protect homes and save lives in these high-density areas. Zooming into the map, the project is located on Luzon, the northern main island of the archipelago. Specifically, we are operating in the heart of Metro Manila, the nation's capital and its most densely populated economic hub. Located in the eastern sector of Metro Manila, the city of Marikina represents one of the most densely populated urban environments in the region. Historically, this area serves as a primary natural catch basin during heavy precipitation events. However, rapid urbanization has significantly altered the landscape. Natural processes like soil infiltration and groundwater recharge have been severely hindered, creating a disrupted or half-water cycle. To mitigate the impact on thousands of households, a series of anti-flooding projects are being implemented. By installing our high-capacity drainage systems here, we are not just moving water, we are providing a critical technical intervention to save property and, most importantly, lives. Logistically, the window for construction is extremely tight. Due to the intense weather patterns of the Philippines, installation can only be effectively realized during the dry months. From July through October, the region is dominated by heavy monsoon rains and typhoons, which can leave construction sites completely submerged. This environmental reality dictates a high-pressure schedule. Open trenches must be kept as short as possible to minimize risk from flooding and to reduce the impact on Metro Manila's dense traffic. In these conditions, the rapid installation speed of our Krah piping system is not just an advantage. It is a technical necessity to complete the project before the waters rise. The core engineering objective of this project is to create a high-capacity intersection between the local creek and the main Marikina River. By strategically redirecting massive volumes of rainwater directly into the river, we can effectively decouple the residential areas from the immediate threat of flash flooding. Technically, we characterize this as a half-water cycle solution. In undisturbed nature, rain infiltrates the soil to recharge groundwater. Here, due to impervious urban surfaces, that natural process is hindered. Our system compensates for this disruption by providing an artificial rapid response drainage path. Given the scale of the runoff, the most effective solution was the implementation of locally produced Krah pipes. Their structural resilience and hydraulic efficiency and the quick installation time make them the ideal choice for this critical urban intervention. The structural integrity and hydraulic performance of our 300 and 500 millimeter pipeline are based on rigorous international engineering standards. The pipe design follows the ASTM F894 framework adapted for metric specifications to meet local project requirements. For the structural load-bearing capacity, we performed comprehensive calculations based on ATV A127 and M55. This ensures that the DN3500 millimeter pipes can withstand the unique soil pressures and seismic demands of the Metro Manila region. In terms of hydraulic performance, the system is engineered to manage a massive flow rate of 26 cubic meters per second. To ensure long-term maintenance and accessibility, we integrated inspection manholes every 40 meters along the entire 1 kilometer stretch. Jointed with our integrated electro-fusion jointing, this creates a seamless high-performance infrastructure capable of protecting the urban landscape for more than a century. When evaluating the best solution for this project, the primary alternative was a traditional steel-reinforced concrete box culvert. However, from an engineering and logistical standpoint, this option presented several critical disadvantages. First, installation speed would have been significantly slower, which is a major risk given our limited dry season window. Second, concrete lacks the self-cleaning properties inherent to the smooth surface of polyethylene pipes, impacting long-term hydraulic efficiency. Most importantly, in a seismic region like the Philippines, a rigid concrete culvert performs poorly during earthquake events. While concrete is prone to cracking and structural failure under ground movement, our flexible Krah pipe solution, joined by integrated electro-fusion, provides the structural ductility and leak-tight reliability necessary to safeguard this infrastructure for the long term. The production of these massive DN3500 millimeter pipes took place locally at the KPMI plant in Cavite, Philippines, utilizing the high-performance Krah KR800 Max machine. To meet the unique requirements of this project, we developed a special project-structured wall design, as standard profiles were not suitable for these specific environmental loads. Each pipe section, measuring 8 meters in length plus socket and spigot, weighs approximately 2 tons. The pipes feature a multi-layer co-extruded construction that is specifically designed to be inspection-friendly. We utilized high-grade Borouge PE 100 or 109LS material, and through our advanced helical winding process, a single pipe is produced in just 4 hours. Every pipe and component comes equipped with an integrated electro-fusion wire, ensuring that the speed of production is matched by the speed and reliability of the installation on-site. One of the most remarkable technical advantages of the Krah system is the ease of handling such large-scale components. As you can see here, a standard lightweight truck is sufficient to transport a pipe with a 3500 millimeter diameter and a length of 6 meters. Despite its massive dimensions, the pipe's advanced multi-layer co-extruded design keeps the weight to approximately 2 tons per section. This significantly reduces the logistical footprint and allows us to use a simple low-bed trailer for delivery. This portability is crucial for urban projects in Metro Manila, where navigating heavy traffic and tight construction sites requires agile and efficient transport solutions. High structural strength no longer has to mean unmanageable weight. The actual installation conditions on site in Marikina are among the most demanding we have encountered. We are operating in a super narrow sheet pile trench with a maximum depth of 7 meters. Due to the proximity to the Marikina River, we are constantly managing little groundwater situation while working just centimeters away from the foundations of old mid-rise buildings. Furthermore, to minimize the impact on heavy city traffic, we are restricted to an extremely short open trench of maximum 15 meters. These tight spatial constraints make the lightweight handling and rapid jointing of the Krah system indispensable. There is simply no room for error when the infrastructure of an entire neighborhood and the stability of surrounding buildings is at stake. The efficiency of this installation is best demonstrated by the timeline of the operation. Take a look at the timestamp. At 10 a.m., the pipe is on the hook, being maneuvered into position. Just 25 minutes later, at 10:25 a.m., the pipe is already fully connected to the next section. At this point, the integrated electrofusion process is ready to begin, securing a permanent leak-proof seal in record time. This rapid turnaround is essential for maintaining momentum in tight urban environments where every minute counts. Once the pipes are positioned, the integrated electrofusion procedure begins. By using two strings of wire, an upper and a lower string, we ensure a precise and tested connection. Because we are working in such a narrow trench, the welding is performed from the inside of the pipe using two EBO X23 Plus machines powered by diesel generators. This 48V DC setup runs for 4,000 seconds, utilizing a simultaneous welding technique. This specific procedure is designed to manage expansion forces effectively, ensuring the long-term structural integrity of the joint. It's a specialized approach that turns a difficult environment into a controlled, high-quality installation. Quality is not left to chance. For every single joint, we generate a comprehensive welding report that meticulously checks both the assessment and the energy consumed during the fusion. Our monitoring systems are designed to flag critical errors immediately, such as power supply interruptions, emergency shutdowns, or low current levels. Before we move on to the subject of manholes, I want to highlight a unique opportunity for you. If you want to be part of an elite community for large pipe applications, I invite you to join the Krah community for free. This is where consultants, contractors, and clients can talk directly to Krah pipe producers worldwide. By joining, you will gain access to a large database of technical documents to support your engineering and project needs. So now back to the original story. As we continue the installation, we encounter the manholes. Given the large pipe dimensions in this project, the manholes are designed in a tangential way to ensure structural stability and optimal flow. Because a complete manhole of this size cannot be transported in one piece, they are assembled on site. We use electro-fusion to joint every component in all directions, connecting the pipe to the fitting and the fitting to the manhole body, creating a monolithic leak-proof unit. To meet local government requirements, a manhole is placed every 4 pipes. Inside, we use a standard removable ladder. This is a key design choice to maintain full hydraulic capacity during peak operation. Finally, the manhole is topped with a concrete ringlet using standard available parts. This ring is carefully placed so that it rests on both the PE manhole and the surrounding soil. This configuration ensures that traffic loads are distributed effectively across the soil rather than putting direct pressure on the manhole itself. The strength of our manholes lies in the quality of their fabrication. Every component is crafted using standard tools, predominantly with wood blades, and joined using advanced extrusion welding machines. To ensure the highest level of structural integrity, we use welding rods in both black and yellow that are produced from the exact same material as the pipe itself. By manufacturing these rods on a specialized Krah welding rod production machine, we guarantee a homogeneous weld. This material consistency means the joints are not just connections, they are a physical continuation of the pipe and manhole body, ensuring long-term durability, even under the most demanding conditions. Beyond the material bond, the physical design of the manhole is engineered to handle significant external forces. The manhole is equipped with 8 stiffeners. These structural elements are strategically placed to ensure that all vertical and lateral loads are transmitted correctly through the body of the manhole. By reinforcing the structure this way, we provide the necessary stability to handle deep burial depths and heavy traffic loads without compromising the integrity of the PE system. This combination of precise fabrication and reinforced design is what makes these manholes a reliable pillar of the city's new infrastructure. The manhole is jointed in the same way as all the other pipes with the same electro-fusion system. Practicality and performance go hand in hand when it comes to manhole maintenance. To facilitate entry, a specialized mobile ladder system was implemented. By utilizing a mobile rather than a fixed system, we avoid having too many permanent structures inside the manhole. This design choice is critical for keeping the hydraulic capacity high, ensuring that the flow remains unobstructed and efficient throughout the system's operation. It's a simple yet effective solution that balances the need for human access with the technical requirements of high-volume water management. Even with the best planning, large-scale projects often require on-site adaptations. During the backfilling stage of a manhole, we received a special request from the customer, the addition of an 800 millimeter inlet. Thanks to the unique material properties of the system, we were able to respond immediately. In the shortest time possible, a DN-ID 800 millimeter solid wall pipe inlet was welded directly into the manhole structure on-site. This demonstrates the immense advantage of our thermoplastic system. It isn't just a precast product, but a flexible engineering solution that can be modified even while the installation is already in progress. The final technical challenge lies in the backfilling process. With the trench having an average width of only 4.4 meters, standard methods were insufficient. And to ensure the stability of the installation in these tight quarters, we employed a specialized method known as vibrocompaction. This technique ensures the soil is densely packed around the structure, providing the necessary lateral support. Furthermore, sandbags were strategically placed to provide a stable and consistent backfilling for each individual pipe. Even for a pipe as massive as the ID3500 millimeters, stability starts from the ground up. Before each section is laid, the bedding is meticulously prepared, including a slight preforming of the pipe bed. This specialized shaping ensures that the lower triangle area of the pipe is backfilled properly, providing uniform support across the entire base. To maintain safety and control in this dense urban environment, the installation proceeds in short trench sections, with an open part occurring every 10 meters. These final measures, combining preformed bedding with controlled excavation, ensure that the infrastructure is perfectly positioned to serve the city for the next century. Efficiency continues immediately after the welding process is finalized. To maintain the tight schedule and ensure structural stability, the backfilling begins directly after installation and welding. Utilizing vibrocompaction to handle the challenges of the very narrow trench, we secure the pipe in its final position. Only once this support is fully established do we proceed to the final step, the removal of the sheet piles. This carefully orchestrated sequence, welding, immediate backfilling, and then pile extraction, is what allows us to operate safely and effectively in the heart of the city's busiest corridors. Basically, directly after backfilling, a layer of lean concrete is added before the asphalt will be applied. The final step in our installation is the seamless integration of the system into the city's infrastructure. To complete the manhole, the cover is embedded into the street using standard ductile parts and a standard concrete ring. This construction is deliberate. By using these components, the street and traffic loads are transformed and distributed primarily into the surrounding soil, rather than being placed directly onto the pipe structure. This ensures that the entire system, from the 800 millimeter specialized inlets to the heavy-duty manholes, remains protected from the daily stresses of urban traffic, providing a reliable and durable solution for decades to come. The ultimate goal of our high-speed installation process is to minimize disruption to the city's heartbeat. Following the successful backfilling and the removal of the sheet piles, the final layer of asphalt is applied to the road surface. Because of the efficiency of the Krah system and our specialized urban installation techniques, we are able to nearly directly reopen the street for traffic. This project stands as a testament to how modern engineering can deliver massive infrastructure improvements like these DNID 3500 millimeter pipelines while keeping one of the world's most densely populated cities moving. Reflecting on this project, we have identified several key areas where we can further optimize future installations. One significant challenge was the dilemma of pipe diameter tolerances, finding the perfect balance between pipes large enough to join but small enough to weld effectively. Our solution was the implementation of the Chilang procedure. We also recognized the need for better customer education regarding technical solutions that have long been standard in Europe, such as advanced methods for connecting plastic to concrete. Looking forward, we see opportunities to increase the distance between manholes and improve the earlier planning of inlets so they can be pre-built rather than adapted on-site. By addressing issues like pre-deflection and refining our vibro-compaction techniques, we continue to push the boundaries of what is possible in urban pipe engineering. Ultimately, the success of this project was driven by the availability of the Krah pipe system, an easy-to-use, reliable solution with a long lifetime and low maintenance costs. Supported by a strong technical backup team, we have delivered a high-performance system with a low total investment cost. By providing advanced plastic solutions, we are not just building pipelines, we are significantly reducing the total cost of ownership through durability. At Krah, we are committed to making the world better and more sustainable, one joint at a time. The scale and importance of this infrastructure project have not gone unnoticed at the highest levels of government. In August 2025, the Philippine President, Marcos, personally visited the site to inspect progress. This visit served as a powerful validation of the work being done. It confirmed that this was no mere ghost project, but a tangible, real-world engineering success. Seeing the DNID 3500 millimeter pipes being successfully installed in such a challenging urban environment reinforces our commitment to delivering infrastructure that truly serves the people. A project of this magnitude is only possible through the collaboration of dedicated partners. Now, we would like to extend our special thanks to KPMI, the qualified Krah pipe producer and community member in the Philippines, the Department of Public Works and Highways of the Philippines for funding this project under GAA 2022, 2023, and 2024, Anoray Construction from Rizal, the main contractor on site, and the local government for their unwavering support throughout the installation. If you're ready to revolutionize your infrastructure, join us at community.Krah.net. Find your nearest Krah certified pipe producer, or if you can't find one nearby, become one yourself. Before I say goodbye, a small reminder: stop using copy-paste engineering from the last century.